For this lesson, we shall graph and write equations of parabolas. One of the applications of parabolas is to make water heaters like the one you see here. And from what you can see, the heat source is the focus, and the heat is concentrated in parallel rays. And moving on, you also see other applications like on satellite dishes, the ones you use to receive TV signals. And some vocabulary we got to know is here. So the focus, this is the line, this lies on the axis of symmetry. You can see the parabola here lies on the axis of symmetry, and here the directrix is perpendicular to the axis of symmetry. This line is the directrix right there. And what else do we see? So there's a directrix here. You can see the vertex lies halfway between the focus and the directrix. And from the definition we are saying the parabola is a set of all points equidistant from a particular line called the directrix and a particular point called the focus. So we are talking about that distance. See, this distance is going to be congruent. Like you can see even right here, see this distance is equal to this. This diagram is not drawn to scale, so it may not be very evident as you see, but any other distance, see like this one, is going to be congruent to that. That has to make 90 degrees. And we also have something else I need to mention here, and this is the focal width, and the focal width is that distance here going through the focus, touching the sides of the parabola. And here, if you make a cross section, you can see where the parabola is coming from. And let's look at some standard equations of a parabola. And here we are starting our focus with the parabola based at the origin. So if the parabola opens up and down, so this is going to be the equation. The focus is going to be given by 0p directrix by that equation. And you can see the axis of symmetry is the vertical. That's the y-axis. The x is equal to 0. And what about if the parabola opens sideways? The equation is right there. The focus, direction, directrix, and the axis of symmetry is horizontal. And you can look at the details on these diagrams right there. Okay, let's now do some examples, because examples will help us to understand it more. Here we are told identify the focus and directrix of the parabola. So this is the equation given. The first thing I would do with this one is to rewrite it to look like, so that it looks like this equation. So rewrite this one to make it look like this equation. So how am I going to do that? I'm going to multiply this side by 4. That's why I can get rid of that 4. And the other side I multiply by 4. So what do I end up with? My new equation becomes y squared is equals to 4x. And now the next thing I'm going to do, I'm going to take that 4p, equate it to 4. So I'm going to write 4p is equals to 4. So that means p is equals to 1. What does that mean? The focus is 1, 0. The directrix is going to be given by x is equals to negative p, so negative 1. So that's how the equation, that's the information I'm told to get, is going to look like. And just remember the equation I have here is equals to y squared is equals to 4x. Okay, now let's move on. And remember, I could rewrite this equation by finding the square root of both sides, plus or minus 4x. I can do that if I want to graph it like on a calculator. Okay, so here, so this is the equation we got on the previous, on the example. We are now going to graph it. So we know that P is equals to 1. We got the forecast. So the forecast is 1, 0. So 1, 0 right there. That's our forecast. Remember, it's based at the origin. Directrix is right here, that line. And I'm going to graph this function. See, the center is right there. And the focal width, remember the equation we had before? Remember the equation was equal to y is equals to 4p, no, not 4px, just 4x, because x was 1. So this was the equation. So the focal width is going to be given by absolute value of 4, which is just 4. So from the forecast, I know the focal width is going to be 4, so I just need to go up 2 units. So remember, this is the forecast right there is 1, 0. So 1, 2, then I go down 2, and then I just connect, and I have my parabola. Another way to do this would be to just use the equation. Remember, y, use the equation we came up with, and you just get a convenient point. So the equation was y is equals to plus or minus square root of 4x. And then you say when x is equals to 1, so you plug in 1 here into this equation, you get plus or minus square root of 4, which is equals to plus or minus 2. And see, that's the same thing I got there, but that's a parabola, just like we got there. Okay, and when you use technology to graph it, that's how it's going to look like. Okay, we do another example. So here we have the equation. Again, the first thing is to multiply by 4. Actually 4/3, because we want this to be totally gone. So what is my new equation? So y squared is equals to 4/3x. Not actually a new equation, I just simplified. So that means 4p is equals to 4/3, and then I'm going to divide by 4, so I get p is equals to 1/3, and so the forecast is going to be 1/3, 0. Directrix is going to be x is equals to minus 1/3. And let's rewrite the equation here, because we shall use it on the next page. Y squared is equals to 4/3x. See, that's the equation. And remember, we could rewrite it so that we can graph it on a calculator. So we get the square root of both sides, and that's how it's going to be. We get the square root of both sides. Now let's go to the other side. See, this is the equation we wrote there. This is the same information. So if I wanted to graph it, I can go here and do 1/3. Okay, right there. And if I plug in 3 into this equation, I'm going to get 4/3 times 3 plus or minus which is equals to, and by plugged in x is equals to 3, because I'll be able to get rid of this decimal, and I'll be able to get the square root of 4. See, this is going to be plus or minus 2 4y. Okay, so when x is 3, so this is going to be 2, and this is going to be minus 2, and there is my parabola there. See, for this one, it was easier for me to plot a point into this equation than to use the focal width, because the focal width is 4 thirds, and that will have been trickier to include in the graph, or to graph the fractions. And here is the equation. When you graph it on a calculator, you can do this on decimals. Okay, we go to another one. Now here we have a graph. You're just supposed to like the equation. So the axis of symmetry is, this is on the y, x is equals to 0. What is the focus? This one is opening downwards, so it's going to be t0, -1, right there, focus. Directrix is x is equals to minus -1, which is 1. So that means, see the p value, you see the p value here, p is equals to -1. So the equation, the parabola is opening down, so it's x squared is equals to 4py. P is 1, so it's going to be x squared is equals to -4y, and that's the equation. Okay, the next one here, we are given, this is the parabola given, the axis of symmetry is on the horizontal. So what do? The focus here, I see, is half, 0. The directrix is -1/2. The equation, so see the p here is 1/2. So now the equation is 4 times 1/2. So that's going to be 4, not 4. 4 times half is 2x. Y is equals to, y squared is equals to 2x. So there is the equation. Okay, and see this, that's the equation we go. Now let's go to this one right here. So find the equation in standard form of a parabola whose directrix is the line x is equals to 3. Let's just sketch it so that you can see where it's opening. X is equals to 3, that's the directrix. The focus is at 1, 2, 3. So that's the focus right there. So, and we know the center is here, so we know it's opening in this direction. It's opening in that direction when we sketch it. So we know P is negative, so that means P is -3 because it's opening to the left. And the equation is going to be y squared is equals to 4px as a general form for a parabola opening sideways. So y squared is equals to 4 times -3 times x, which is equals to -12x. So that's the equation here. And if you got the parabola, see, that's the way it would look like.